All right, today we're talking about exponents. So let's talk about some of the rules of exponents. Let me get this set up here. All right, so we're going to talk about the rules of exponents. All right, so a couple of things. One is, let's say, for example, that if I have x squared times x cubed, okay? Actually, you know what? I will do one better. I'm going to say that this is blue. There we go. So then I can say, then I can say that if I was to expand x squared out, it'd be x times x. And if I expand x cubed out, it'd be x times x times x. So essentially, I could rewrite this as x to the fifth. So the question is, what did I do with the 2 and 3 to get 5? That's right, I did add them. So if I have a to the m times a to the n, in other words, same base, different powers, I add the 2 powers, okay? Now, similarly, if I said x squared divided by x cubed, all right? So what essentially I can have here is top is x times x, and the bottom is going to be x times x times x, all right? And with that being said, the way I want to look at it is, let me actually use the boxes. So if I look at just this right here, x divided by x is just 1, right? And if I, let's say, look at this one right here, same thing. X divided by x is also 1. So essentially, I could cancel this out. I can cancel these out because they're going to equal to 1. So what do I have left? I have 1 over x. Okay? Well, that doesn't really tell me much. So let's do another example. Let's say it was the other way around. Let's say it was x cubed divided by x squared. Okay? So the top would be x times x times x, and the bottom would be x times x. Well, let's use the same idea, right? X over x goes to 1, and then x over x is also equal to 1. So what do I have? I have just x. And if I just write x, that means it really is the first power, right? All right, so that means what did I do with a 3 and a 2 to get 1? Well, then if I have x, I was using a, so a, if I had a to the m, actually, let me do this. A to the m divided by a to the n, I would have a to the m minus n. So yes, you are right that this then would be x to the negative first power because 2 minus 3 would be x to the negative 1. Now, this is kind of an important case here because we will get to that. You will see that appear again very soon in the rules here, but that's essentially the same idea and the same rule, and we'll get to what x to the negative 1 power really means, all right? Next one is saying, okay, what if I had x squared raised to the, you know what, let me do this, raised to the third power. And the reason why I wrote it this way is because the power of 3, the power of 3, the exponent, that's 3, actually has, how should I say this, is attached to something, okay? It is attached to the parentheses. It's not attached to x squared, it's attached to parentheses, all right? And that's why I wrote the parentheses in blue as well. This means that I'm going to write that parentheses 3 times because that's what x cubed means, okay? What's in the parentheses? X squared. Well, what's x squared times x squared times x squared. Well, that's essentially going to equal to x to the 6th power. Or what did I do with the 2 and 3 to get 6? Well, that means a to the m raised to the nth power. I would say that it's a to the m times n. Okay? So notice that these two here are right next to each other. So maybe that will help you remember that we will multiply them, because it's pretty much saying, like, for example, m times n, right? So it's the same idea, all right? So if you want to think of it that way, you're more than welcome to, all right? And then we're here, don't mistake that for that rule right there, okay? That's very different. And the reason why I'm giving you these simple examples is because in case you freeze on the test, you can just write this out and say, okay, let me cancel these out. That's what I got, so what did I do with the powers to get that? Or if I was to expand this out, what did I do with the powers to get the 5, right? So that this way you can kind of get a general idea of what it is and then go, this is pretty simple, I got this, okay? All right, so the next thing is, what if I had, let's say a times b raised to the 2nd power, okay? So like I said before, that the power is touching the parentheses. So that means I have to write the parentheses twice. And what's in the parentheses is a times b. So if you look at this, essentially I have a times b times b. So that's going to give me a squared, actually. I'm going to get a squared times b squared. Well, notice what happened from here to here, right? What happened was that if I have a times b raised to the m power, then a is raised to the m power times b is raised to the m power. So it's kind of like distributing the powers, okay? Let me see what else is there. And the same happens for division. So if I had a divided by b raised to the nth power, then I have a to the nth divided by b to the nth. All right, same idea, just with multiplication and ones with division, okay? And then we have, and then some of these rules we don't really need. So let's think of it this way. I'll keep on putting down rules here with no examples. So if I had a to the 0, anything raised to the 0 power is going to be 1. And if you don't believe that, put that in your calculator. Do like 9. So to put that in your calculator, you'll do 9 to the 0. Let me see. Would be 9 caret 0. Okay. What's the other things that you might see for that? Let me see. Another way to look at it is you might have the button, I think it's x to the y or y to the x. Okay, so depending on what calculator you have, you might have a caret, you might have a button that is y to the x or x to the y. All right, that will also give you, it will show you that it's equal to 1. And to be fair, maybe what I need to do is this, just so that you kind of know the difference of which rule is which, so that you don't go, is this for this one or for this one or for this one? There we go. I'll just put that up here, bring this up, bring this down just a little bit, there we go. And then the next one is kind of crooked, there we go. And let me put another one down here so that I can go to the next one. Okay, so the next one is anything raised to the 1st power is equal to itself. So like x, if I just write the x, then you know that's really x to the 1st. All right, now here is where you're going to see this one. So a raised to the negative nth power is actually equal to 1 over a to the nth power. And you're going to understand this once we get into doing problems, and I'll explain how to think of it that way. But if you notice that this rule right here, we really already did with this right here, right? Except it's backwards, right? We have this because we subtracted these two powers here, right? And then we got 1 over n if we kind of did the work that way, right? All right, so let's go back to here, all right? Now with that being said, it's also true that if I have a divided by b raised to negative nth power, what would happen is this. It'll be b raised to the a to the positive nth power. Okay, so I want you guys to understand that. All right, so now let's do some problems so that it can kind of explain things the right way for you. All right, so the way I look at it this way. Oops. All right, so let's say I have an example here. And it is a to the fifth, b to the negative 1, and c to the negative 8. Okay, so remember before when I said we can always write anything as a fraction, right? Oops. There we go. All right, anything as a fraction. So what we're saying is this. So I want to think of this as a fraction as well, but just over 1, right? So if that's the case, this is the way we look at it. If they don't like being on top, then we're going to allow them to be on the bottom so that they will be happy. And if they don't want to be on the bottom, we put them on top so they can be happy, okay? So think of it that way. And you can think of it as classes. If you don't like to be in one class, you're going to just be miserable. You're going to complain all the time. You're going to be negative, right, in the head. So you're going to just not give it any effort. So you want to be in the other class. So they're like, okay, fine, we'll put you in the other class so you can be better behaved. You get to the other class, you're like, woohoo, I'm in this class. I'm happy. I'm going to put forth some effort. Think of it that way, all right? So if you look at a to the fifth right now, so essentially all we're looking at right now is a power, okay? So I'm going to look at each of these as separate powers, okay? So if you look at a to the fifth right now, it has a positive exponent or positive power. That means a is positive, or positive in terms of power. So we're going to keep a right there. But if you look at b to the negative 1, the power is negative, all right? They kind of don't like it to be in this class. So we're going to let them move to the bottom, okay? Actually, I would just write it down that way, okay? So now they can be happier there. And C clearly does not like being on the top. So we're going to let C come down to the bottom as well. So when they move, they flip the powers, okay? The power is either from negative to positive or positive to negative, okay, depending on how you move them. So if I was to move the A down to the bottom, let's say, it'll be A to negative 5, okay? But we're never gonna do that. And the only reason why we're moving them is because mathematically speaking, we do not like negative powers. So that means this is gonna really equal to A to the 5th over B times C to the 8th. Okay. All right. I don't know. I hope that helps. All right. Let's do another example of a common mistake, like negative 9 raised to the 0 power. Okay. Your first move is going to be like, oh yeah, I know that. That's just going to be 1, but that's not true. Okay. So order of operation tells us to go with parentheses, exponents, right? And then multiplication or division from left to right. So if that is the case, when we do the exponent part, okay, I'm going to ask you, what is the power attached to? Now, up here, we talked a lot about that the power was attached to the parentheses, okay? So since this one doesn't have a power or parentheses, so the 0 is not attached to the parentheses, but this 0 is attached to the 9. So essentially what we're doing is we're doing this piece first, and then we're going to negate whatever that result is. So we know that this is going to be a negative 1. You know what? Let me do one better than that. So inside the parentheses will give me 1. It's going to give me 1. So that's why the result would be negative 1. There we go. That looks better. Okay? Now, if I had it as this, then that, my friends, would be 1. Because the power is attached to the parentheses. So the parentheses is being raised to the 0 power. So therefore, that's why it's just 1 versus the other one. All right? So let's do another example. Let's say we have 2x to the 0 power plus 4. Okay? What is the power attached to? It's attached to the x. Okay? So in other words, just this part right here is done first. So really I have 2 times 1 plus 4, which is actually equal to plain old 6. There we go. All right. All right. So enough with those 0 powers. I just want you guys to understand those. I think those are important. So let's take a look at the next problem here that I have. All right. So I have another example here. This is 35, x to the 3rd, y to the 4th, over 10x y squared. Okay, so this is the way I want to look at these ones. All right, so first things first, so the numbers are the numbers, the variables are the variables. So essentially what I'm doing is I'm segregating. Okay, so I know this is not like I don't like the word segregate, but that's what we're doing. So let me do it this way. So let's say I have the 35 and the 10. I have the x cubed with the x, and then we have the y to the 4th with the y squared. Okay, so you want to take these individually and break them down. Okay, so if I was to break this down, what I would do is look at the 35 and 10. What goes in the 35 and 10? Okay, what goes in the 35 and 10? Let me see, 5 does, okay? 5 goes in the 35 7 times and goes in the 10 twice, okay? So that means I have a 7 left and a 2 on the bottom. Now, the next part, the exponent, the variable part, x cubed over x. Now, I traditionally do not like this rule right here. I do not like this rule whatsoever, okay? Because the students tend to get confused because if they get an x to the negative 1, they're not sure if that is in the numerator or the denominator. And the truth of it is, it's actually always in the numerator. Is always on, that result is always on top. The way I like to look at it is, essentially if I was to expand it, right? There's 3 x's on top. There's 1 x on the bottom. One of them cancel out, and I have 2 x's left on top. Okay, so that's the way I like to look at that. All right, so essentially what I have left here is just an x squared on top. All right, I can't forget about the 7 and the 2. And then the orange, so I got 4 y's on the top. 1, 2, 3, 4 over two y's on the bottom. Y cancels out. I have two y's left on top. Okay. So now I can finish off my answer by saying that the answer is 7x squared y squared all over 2. And that would be my answer right there. You doke? All right. Hopefully that will help. If you have any questions, let me know, bud. All right, let's take a look at another part right here. Ooh, this one is interesting. So this is negative 7x to the negative 5. So again, I want to think of this as being over 1 as a fraction. Okay? So if I had this as a fraction, so here's the thing. Yeah. So I look at just the negative 7. Now, the negative 7, what power does it have? Right? What's a power? It's a 1. And it's a positive 1. So therefore, the negative 7 doesn't move whatsoever. Okay? It's only of the power. All right? All right? It's your brain. It's up top. All right? If that's negative, then everything's negative, right? If that is positive, then everything's positive. Okay, so now let's look at the x to the negative 5th. Again, it's a negative power. It doesn't like being on top. That's the reason why we would let it be on the bottom. And that would be your answer. Okay? All right. I got a couple more problems for you guys. All right. Now, so far, these ones have been the easier ones. Let's get into something a little tougher. All right, so let's say it's 6, a to the negative 5, b to the 6th over 18, a to the 3rd, b to the negative 4th, okay? So if there's no parentheses, what we want to do is start segregating and moving them. Okay, so the first thing I'm going to ask is this. You know what? Let's do this. So that is all. It's all right. It'll keep on changing anyways. So that's going to be blue. And then this is going to be in orange. And there we go. All right. So we look at the numbers. What goes into 6 and 18? 6 does. 6 goes into 6 once and goes into 18 3 times. So that means I have a 3 left on the bottom. Okay? But I usually don't like to reduce until after I move them because these numbers could essentially have a negative exponent down the road. So usually I don't. So let me go back here. And let's just say that I'm going to just leave them because 6 has a positive exponent. The 18 has a positive exponent. Awesome. The a to the negative 5. The a has a negative exponent. So I want to bring the a to the negative 5 down to become a to the 5th. The a cubed is positive, so it likes being there. So we're going to keep it there. Okay. Let's look at b to the 6. B to the 6 likes being there. B to the 4th, b to the negative 4th does not like being on the bottom, so we're going to bring them up top. Okay? So now I tend to reduce and say, okay, 6 goes to 6 once and 18 3 times. So now I have a 1 on top. What else do I have? I have b to the 10th on top over, what do I have on the bottom? I got that 3. And then how about the a? I got a to the 8th on the bottom. So therefore, that is so this is kind of like the way we would do word problems, right? We see the whole problem, and then we kind of break it apart, do piece by piece by piece, and then put them finally back together to get the answer, all right? Let's see, what else do I got for you guys? There's a longer homework assignment. It wants me to go back to the zeros. Zero exponents. So if I had 4 to the 0 minus 8 times z to the 0, what would that be equal to? Well, remember, what is the 0 attached to? It's attached to the 4 and the z alone. Okay, so that this is going to be 1 minus 8 times 1. So I'm going to have a negative 7. Whoa. Not what I was expecting there. There we go. All right. All right. And I think that will be all the examples I'm going to go through. So this will be the end of the notes. And you guys have any questions? And, in the next section, we're going to actually do more of these, a little more difficult.